The London Design Biennale exists to promote design and the breadth of the subject of design, and also to facilitate international dialogue and exchange. Of course, this year, the international aspect has been challenged on a number of levels, but we still wanted to present the work that was going on in the area of sustainability and innovation. So we have a special section this year of the Biennale that's dedicated to that, and unfolding the Cambridge piece fitted into that so brilliantly. We're very pleased to be able to present it here.
I'm Antiope Koronaki. I'm a research associate in the Center for Natural Material Innovation at the University of Cambridge, and I would like to introduce you to the Unfolding Pavilion, which explores how we can use nature-based solutions to address the challenges of the built environment, such as climate crisis and shortages in urban infrastructure. So through this work, we try to explore and study how we can think about the future of design and the challenges that we as architects and engineers are facing, which are the climate crisis and the shortage in urban infrastructure. And we're trying to see how we can address these challenges through nature-based solutions. And timber is a very good answer to these problems because it's a natural material that we can grow, and it addresses the climate crisis by sequestering carbon by growing, and at the same time the fabrication and assembly process of engineered timber is very much directly linked with modern methods of construction. So where engineered timber elements are prefabricated and they're assembled very quickly, so this means that we can address the shortages in a very quick and precise way and build our new homes with materials that we can grow in our forests. So in this pavilion, we wanted to create three-dimensional folded structures, flat-packed plywood sheets. So the material we're using here is birch plywood, and the main structure has a 6 mm thickness, while the bases have 18 mm thickness. The challenges we had for that was, first of all, we needed to come up with a way to treat timber so that we would be able to fold it. And the other ways, we had to come up with a folding pattern that would make it stiff and that would, in relation to the exhibition, it would fit well in the space and create an experience that would engage the public. So the answer to the material treatment is kerfing, which is a process in which you can remove material in a specific pattern, and this makes the flat sheet flexible so you can fold. The other challenge is the folding pattern. So what lines and how we're going to fold timber, because depending on how you fold it, you create different levels of strength and stiffness in the final structure. So there were two main streams of work, one looking into the material properties and one into the folding. And these were all integrated into a seamless workflow from physical experiments to digital modeling and then fabrication and assembly and disassembly essentially. The pavilion has been designed in a way that it can be assembled and disassembled without any, as many times as we want. And I can show you through the very small connectors, taking advantage of the friction of the material and of the design of the connections. Some of these structures have been disassembled and assembled 3 times by now. So the goal is, after the exhibition is over, to disassemble it and exhibit it somewhere else, so that we would both demonstrate how prefabricated timber structures can be disassembled if you take that into account early on in the design, but also, of course, try and engage more public and raise awareness of how nature-based solution can be an answer to the challenges we face. One of the main challenges that we've all had to face in the past year is the need for our homes and spaces to be adaptable. So one space needs to be able to accommodate different uses both throughout the day, but also throughout the occupancy from a single user, and especially while uses change throughout the lifetime of a building. So being able to fold timber elements means that we're able to develop flexible partitions that we can then use in housing and school buildings and in infrastructure projects that can help us have different, accommodate more complex living scenarios that correspond more to what is actually, to how users are actually using the buildings. And this is part of the research of Anna Gatto in our research center, who has been leading this project. And she's looking into how we can use curving as a method to treat and fabricate timber components from flat pack elements to create flexible partitions.